Now let us see this question. A uniform sphere of mass m and radius r rolls without slipping on an inclined plane at an angle of theta. Find the coefficient of friction at which slipping is absent. Kinetic energy after t seconds of motion. So, if I draw a diagram of this one, then from here, a sphere here in the sense it is a solid sphere. So this solid sphere, it is rolling at an angle of theta, which is the inclined plane. Then we are supposed to find out the coefficient of friction at which slipping is absent. It means this body is rolling in this condition, and the minimum coefficient of friction required for a body to roll, already we have discussed in the theory part. So mu minimum is equals to tan theta divided by 1 plus r square divided by k square. So we know k square by r square value for a sphere is equals to 2 by 5. So therefore r square by k square value will be equals to 5 by 2. So if I substitute in this relation, so mu minimum is equals to tan theta divided by 1 plus 2 by 5. K square by r square value, it is 5 by 2. So therefore it is equals to 2 tan theta divided by 7. So which is equals to 2 by 7 tan theta. So this is the minimum coefficient of friction which is required for this body to roll without slipping. So now second question is also asking, find out the kinetic energy after t seconds of motion. So final kinetic energy, which is the sum of translational kinetic energy plus rotational kinetic energy, we know the formula is how half I axis into omega square, or also I can write half mv square into 1 plus k square divided by r square. So therefore for this one I require final velocity, which can be calculated by v is equals to u plus at. For this one again I need to calculate acceleration, and the equation of acceleration we have already derived, which is equals to g sin theta divided by 1 plus k square divided by r square. So g sin theta divided by 1 plus k square by r square value for a solid sphere is 2 by 5. So therefore a is equals to 5g sin theta divided by this value is 7. So 5 by 7g sin theta is the equation for acceleration. So by using acceleration equation, I can calculate final velocity, v is equals to u plus at. So initial velocity at rolling is 0. So acceleration is 5 by 7g sin theta, and time taken is t. So if I know final velocity, I can substitute now in this relation. So total kinetic energy after a time of t is equals to half into m into, instead of v square I can write 5 by 7g sin theta into t whole square into half of k square divided by r square. K square divided by r square for a sphere is 2 by 5. So therefore kinetic energy is equals to half into m into, so 25 by 49 into g sin theta into t square. So this is 7 divided by 7 divided by 5. So if I do this total calculation, then the answer which I should get is kinetic energy is equals to 5 by 14 mg square sin square theta into t square. So this will be the total kinetic energy after a time of t seconds. Now let us see this question. A ring, a solid cylinder and a solid sphere, all having same mass and radius, are released from top of an inclined plane. Friction coefficient is same but not enough to provide pure rolling. So first question is, which body will reach the bottom first, and which body will have minimum kinetic energy at the bottom. So this we are supposed to find out. So here these bodies are rolling only because of friction, but here it is given that the friction is not enough. such that the bodies will roll. So we have already studied that bodies will roll, that is, bodies will have pure rolling if the amount of friction required, if F is less than or equal to limiting friction. So if the required friction for rolling, if it is less than or equal to limiting friction, then only the bodies will roll. And if the amount of friction required, if it is greater than limiting friction, then a friction greater than limiting friction is not possible. So therefore these bodies will not roll. So already we have studied that F is equals to IA divided by R square when bodies are rolling. So when this friction required is such that if it is greater than limiting friction, then bodies cannot roll, because a friction greater than limiting friction is not possible. So therefore F should be less than or equal to FL. So now the condition is, if the bodies are not rolling, then what is the friction which is acting? If the bodies are not rolling, then the maximum amount of friction which is present is limiting friction. So definitely I can say limiting friction will act on these bodies. So therefore if I draw this diagram, so if it is any body, circular body, then this is mg sin theta, this is FL, this is mg cos theta, and this is angle theta. This is the angular acceleration with which bodies are rolling. So therefore if friction is less than limiting friction, now on this body the amount of friction which is acting is only limiting friction, which is a standard value. So mg sin theta is a constant for any body, and limiting friction is also constant because our bodies are not rolling here. So therefore if I write the equation for linear motion, then I can write mg sin theta minus FL should provide mass into acceleration, which is the net force. So mg sin theta should be greater than limiting friction. So mg sin theta minus FL is equals to mass into acceleration. So mg sin theta minus FL is mu s into n is equals to mass into acceleration. So mg sin theta minus mu s, n value is mg cos theta, is equals to m into a. So m gets cancelled. So a is equals to g into sin theta minus mu s cos theta. So this value is a constant for every body, because no body is rolling here. All the bodies, they are sliding as well as rolling. So therefore acceleration for every body remains the same. If acceleration for every body remains the same, then final velocity with which they reach the ground, v is equals to u plus at. This is also same for every body. So every body will reach the ground with the same velocity and in the same time, because all of them are having the same acceleration. So as all the bodies, they are reaching the ground with the same velocity, definitely I can say linear kinetic energy is the same for all the bodies. So kinetic energy is a sum of linear kinetic energy, that is translational and rotational kinetic energies. Out of them, linear kinetic energy is the same for all these bodies. Now let us discuss about what about the rotational kinetic energy. So K rotational is equals to half I into omega square. So if I can calculate omega value, then I can calculate rotational kinetic energy. Omega can be calculated as omega naught plus alpha into T. So let us see how we can calculate alpha value. So torque provided by friction, F into R is equals to I into alpha. So therefore alpha is equals to Fr divided by I. So if I substitute in this relation, omega is equals to omega naught plus Fr divided by I into T. So omega is equals to initial angular velocity is 0 plus Frt divided by I. So this is our angular velocity by the time it reaches the ground. So therefore, if I substitute in rotational kinetic energy equation, kinetic energy rotational is equals to half into I into omega square. So FRT divided by I whole square. So here I have I square, here I have I. So therefore I can write rotational kinetic energy is inversely proportional to moment of inertia. So therefore the bodies which have highest moment of inertia, they will reach the ground in a that is in the last they will reach the ground. So therefore definitely I can say ring has highest moment of inertia. So ring will reach the bottom at the last. And also, as rotational kinetic energy is inversely proportional to I, ring has minimum kinetic energy. Ring has minimum kinetic energy. Kinetic energy means the sum of translational kinetic energy and rotational kinetic energy. Translational kinetic energy for every body is same, but rotational kinetic energy of the ring is the minimum. So therefore ring will have the minimum total kinetic energy. Dear students, now let us see this question. A horizontal force is applied at a height h above the center of a solid cylinder of mass m and radius r. Determine friction if cylinder rolls without slipping. For what values of h friction is 0. So therefore, if I try to draw this diagram, then this is a solid cylinder and this is radius r. So we are applying force at a height of h above the center of the cylinder. So that is, I am applying force here. So this is the position in which I am applying the force. So what we are supposed to find out, first of all we need an equation of friction, and for what values of h this friction will become 0. So if I am applying force here, I don't know what will be the direction of friction. So friction may be acting in this direction, friction may be acting in this direction. So we don't know what is the direction of friction. So we will assume some direction of friction and we will assume the conditions. So finally, if that friction becomes positive, then my assumed direction is correct. Or if the equation of friction has become negative, then it means my assumed direction of friction is wrong. So therefore, I will consider this direction of friction. So I will assume friction is acting in this direction. So now I will write one equation for rotational motion and one equation for translatory motion. By solving both of them, I will try to get an equation for friction. Now writing equation for rotational motion. So this applied force will produce torque. So torque is equals to F into R is equals to I into alpha. Now if I consider my equation of my position of axis to be here, then around this point it is an example of this point has only rotational motion only. So therefore applied force is F. So F into R into at what distance I am applying this force? I am applying this force at a height of R plus H. So F into R plus H is equals to moment of inertia across this point. I can write it is half mr square for a cylinder when axis is present at the center. And now by using parallel axis theorem, I can write mr square into alpha. So therefore, F into R plus H is equals to 3 by 2 mr square into alpha value can be written as A by R. So this R and square get cancelled. So F into R plus H is equals to 3 by 2 mr into A. So therefore A can be written as 2 by 3 F into R plus H divided by m into R. So this is the equation of acceleration which I got. So further I can simplify this one. A is equals to 2 by 3 F by M into 1 plus H by R. Like this also I can write. If I divide this R plus H by this R. So let it be my equation number 1. Now I will apply equation for translatory motion. So how I can apply equation for translationary motion? So on this cylinder, two forces are acting, and this is my assumed direction of friction in forward direction. So F and F, both of them are responsible for providing acceleration to this cylinder. So therefore I can write F plus F is equals to mass into acceleration. So F plus F is equals to mass into acceleration equation already we have calculated. So 2 by 3 F by M into 1 plus H by R. So M gets cancelled. So therefore F can be written as 2 by 3 F into 1 plus H by R minus F. So if I take this F common, then I can write F is equals to, if I take this F common, capital F, so 2 by 3 into 1 plus H by R minus 1. So F is equals to, so F into 2 by 3 minus 2 by 3 plus 2H by 3R minus 1. So 2 by 3 minus of 1 will become minus 1 by 3. So therefore F is equals to 2H by 3R minus 1 by 3. So F 3 if I take a common, then F is equals to 1 by 3 of 2H by R minus 1. Same relation I can write like this also. F is equals to 1 by 3 into H by R by 2 minus 1. Now what is the purpose of writing this equation like this? So by this I can say some conditions. First condition is if H is equals to R by 2. If this H and R by 2 are equal, then they will become 1 minus 1. It will become 0. It means that if I am applying a force at a height of R by 2, then definitely I can say friction acting will become 0. So total height at which I have to apply this force is R plus R by 2, that is at a distance of 3R divided by 2. At this height if I apply the force, then frictional force will become 0. Now second condition is also there. So if this H, if it is greater than R by 2, then H by R by 2 will become positive value and friction becomes positive. It means this was the previous assumed direction, and if I say that H is greater than R by 2, then friction will become positive and my assumed direction of friction is correct. Similarly, third condition, if H is less than R by 2, then friction will become negative. So if H is less than R by 2, this is less than 1. So this value minus 1 will give negative friction. So if the point of application of force H, if it is less than R by 2, then friction changes its direction. That is my assumed direction of friction will become false. So in this condition, friction will become negative. So these are the different conditions for which friction acts in different directions. Now let us see this question. A solid cylinder of mass m and radius r is resting on a horizontal platform. The platform is given a motion in x direction according to x is equals to a cos omega t. If there is no slipping between cylinder and platform, find the maximum torque acting on this cylinder. So let us try to understand this one diagrammatically. So this is the platform on which this cylinder is present. So it is having a mass m and radius of r. So this what you called platform is given a motion according to x is equals to a cos omega t. So here x value is continuously changing with respect to time. So therefore I can calculate acceleration of this motion. So therefore I can write Therefore, if I write equation for velocity, I can write v is equals to dx by dt is equals to differentiation of this equation will give, so minus a omega sine omega t, because differentiation of cos theta is minus sine theta, and omega t also I have to differentiate with respect to time, then I will get omega. So total equation minus a omega sine omega t. So further, if I further differentiate this velocity equation with respect to time, then I will get acceleration. The acceleration is equals to dv divided by dt. So this I will get minus a omega square cos omega t. So again, differentiation of sine theta is cos theta, and omega t also I have to differentiate with respect to time, then I will get one more omega. So minus a omega square cos omega t. And he is asking maximum torque, so therefore acceleration should be maximum, and maximum acceleration magnitude I can write it is equals to a omega square, because the maximum value of acceleration becomes a omega square when cos omega t becomes equal to 1, because the maximum value of cos theta is 1. So this is the maximum acceleration of the platform. So therefore I can write this platform can accelerate with the maximum acceleration of a is equals to a omega into square. Now the question is, if there is no slipping between cylinder and this platform, so no slipping in the sense that the point of contact of this cylinder, this point also should have an acceleration of a omega square itself. So this point of contact and this platform, both of them, if they are traveling with the same acceleration, then definitely there is no slipping in between these 2 points. But acceleration of point P can be written as acceleration of center of mass plus acceleration of point P with respect to center of mass, or I can write acceleration of point P can be written as a center of mass plus a tangential. So both of them are in the same direction. So tangential acceleration also is in the same direction. Acceleration of center of mass is also in the same direction. So acceleration of point P can be written as a center of mass plus a tangential. Now let us see how I can calculate acceleration of center of mass. So on this cylinder, friction is the only force which is applying force on this cylinder, and friction is acting in this direction. So I can write F is equals to mass into acceleration of center of mass. So therefore acceleration of center of mass can be written as F by m, and this is my equation number 1. Now tangential acceleration, let us see how I can calculate. So tangential acceleration is equals to alpha into r. So alpha value, how can I calculate? Let us see how I can calculate alpha value next. So on this cylinder, this force is providing torque also, which can be written as torque is equals to F into R is equals to I into alpha. So therefore F into R is equals to moment of inertia of a solid cylinder is half mr square into alpha. So square and r gets cancelled. So therefore F is equals to half into m into r into alpha. So therefore alpha can be written as 2f divided by m into r. Now take this alpha and substitute in this relation, then I will get tangential acceleration, which is called alpha into r. So therefore 2f divided by m into r into m into r into r. So r gets cancelled. So tangential acceleration is 2f divided by capital M. So therefore acceleration of point P is the sum of acceleration of center of mass plus tangential acceleration. Acceleration of center of mass is F by m, and tangential acceleration is 2f divided by m. So therefore total is equal to 3f divided by capital M. So this is the acceleration of point P. So for a body not to slip, so acceleration of point P and acceleration of this what you called this platform, both of them they should be equal. So therefore I can write 3f divided by capital M is equals to a into omega square. So for this, from this I will try to calculate the equation for friction. Friction is equals to A omega square m divided by 3. So this is the maximum friction which is providing maximum torque. So tau max is equals to R into F. So F max into R. So therefore it is equals to A omega square m R divided by 3. So this is the maximum torque that can be provided by this. So now let us see this question. A uniform cylinder of R and radius of gyration k is kept on fixed wedge of inclination theta. When we push the wedge with a constant acceleration a, cylinder rolls up the wedge. Find the coefficient of friction between cylinder and wedge. That is the question. So let us try to understand this question in the form of a diagram. So this is the inclined wedge on which we are placing a cylinder of mass small m, and this is a wedge of mass capital M. This is angle of inclination theta. So this wedge, we are accelerating this one with an acceleration of a. Now it is very easy if I try to solve this problem from the non-accelerating frame of reference, that is my observer is present here. So for this observer, as this observer is accelerating with an acceleration of a, therefore we have to draw a pseudo force which is m into a, exactly in opposite direction to the acceleration of the observer. So this pseudo force I can always split into two components. So this will become ma cos theta. So if this is theta, this angle is also theta, and this component will become ma sin theta, and some more components of vectors forces are present, which is mg sin theta, the force component, the weight component which is parallel to this inclined plane, and one more force which is present is, that is mg cos theta. So these are the different forces which are present, and if this cylinder rolls upwards with an angular acceleration of alpha, then friction starts acting in downwards direction. So therefore, if I write an equation for a normal reaction, ma sin theta and mg cos theta, they are pushing this inclined plane downwards. Therefore, I will write normal reaction should be equal to ma sin theta plus mg cos theta, and this is my equation number 1. Similarly, if I study about all the forces which are acting parallel to this inclined plane, then ma cos theta is acting upwards, mg sin theta and friction, they are acting downwards. So as the cylinder is moving upwards with an acceleration of a with respect to this wedge, therefore I can write according to Newton's laws, ma cos theta minus mg sin theta minus friction should be equal to m into a dash, where a dash is the acceleration of this cylinder with respect to the wedge. So this is my equation number 2. So now I want to calculate friction, because for a body to roll down, limiting friction should be less than or equal to Fl. So this is equals to mu s into n. N value already we have calculated. Now somehow if I calculate F value and substitute in this equation, then I will get the required mu s value. So for a body to roll down, already we have studied the amount of friction is equals to F is equals to Ia divided by r square. So in this condition we have to solve in terms of radius of gyration, which is called mk square into a divided by r square. So therefore a can be written as, or acceleration with respect to the cylinder is a dash, with respect to the wedge is a dash. So a dash can be written as f r square divided by mk square. So substituting this equation, so in equation number 2, so therefore substituting, let it be equation number 3, substituting equation number 3 in equation number 2, then I will get an equation for friction. So the friction equation which I will get is A is equals to ma cos theta minus of mg sin theta divided by 1 plus r square divided by k square. So this is the relation of friction which I will get if I substitute this a dash relation in equation number 2. So therefore, I got equation of friction. So therefore, for a body to roll, this condition should be satisfied. F should be less than or equal to mu s into n. So therefore, mu s should be greater than or equal to F divided by n. So we have equation for F, equation for n also we have. So if I divide these two relations, then I will get mu should be greater than or equal to a cos theta minus g sin theta divided by 1 plus r square by k square multiplied by a sin theta minus a sin theta plus g cos theta. This is the relation we will get. I hope you can substitute these values and you can get this relation. So this is the coefficient of friction for this cylinder to roll upwards if I apply an acceleration of A to the wedge.